Okay, today we start day 4, which is dividing polynomials using synthetic division. The goal is going to be to divide polynomials using synthetic. I'm going to start by reviewing the idea of long division, and I'm going to use an example that I'm going to do with both long division and synthetic division in order to teach the concept to show how they both end up giving you the same result. So if we start our review of long division, notice that our divisor is x minus 2. We put our little x minus 2 on the outside here, and then we go through and divide, and we have to figure out how many times x goes into 4x cubed, which is a 4x squared times. We multiply our 4x squared by both of the terms in the divisor, and we end up with 4x cubed minus 8x squared. Don't forget that you are subtracting. The 4x cubes are going to cancel out, and then 5x squared minus a negative 8x squared is going to give us a 13x squared. Don't forget you bring the next term down. In this case it's a 0x. I now figure out how many times x goes into 13x squared, which is 13x times. I multiply my 13x by both of these terms, x and negative 2, to give me a 13x squared minus 26x. I subtract. The x squareds are going to cancel out, and then 0 minus a negative 26x gives me a 26x. Bring the last term down, which is our positive 8. Figure out how many times x goes into 26x, which is 26 times. 26 times the x gives us a 26x, and 26 times negative 2 gives us a negative 52. We subtract one last time, and 8 minus a negative 52 is a positive 60. Our 60 here is going to become our remainder, and the way that we write that is by writing 60 over x minus 2. So here's our long division. So 4x cubed plus 5x squared plus 8 divided by x minus 2 gives us a 4x squared plus 13x plus 26 plus 60 over x minus 2. Okay, now we're going to do the same problem using synthetic division. Okay, and just remember, synthetic division, just like long division, can be used anytime when you are dividing by an x minus r term, or a binomial. As in, it can't be used for dividing by monomials, which is like number 14 and 16 in the homework for tonight. Okay, we'll use the same example again, like I said before, in order to teach the concept. All right. So, very first thing that you have to do is you have to set your divisor, which is x minus 2 in this case, equal to 0, and we solve. And in this case, we get x equal to 2. Now, the setup is going to be a little different here. We're going to take this x equal to 2, and we're going to put it in a little box. Okay, so this is going to go in the little box. Okay, and then outside the little box is we are going to put the coefficients of our dividends. Okay, so in this case, the 4, the 5, and the 8, and again, just like we did with the long division, we're going to fill in 0 for that missing first degree term. Okay, so here is our start and our setup to synthetic division. Basically, it's the same thing, it's just as long division, we're just doing it without the variables. Okay, so just one last reminder, anytime that you have a missing term, always make sure that you fill in with a 0. Alright, to start, you always bring the first number down, and in this case that's the 4, and then from there you take the number that is in the box, which is our 2, and you multiply by the 4, which is below the line. Okay, and then this step is going to be repeated over and over and over again. Okay, our 2 times our 4 yields an 8. And now what we're going to do is we're going to add and multiply, add and multiply, add and multiply until we're done. So 5 plus 8 gives us a 13. We multiply 2 times 13, which gives us a 26. We put the 26 underneath the next term. We add. We multiply 2 times 26. We get 52. We add, and we get 60. Since our last number is not a 0, it is now a remainder. Okay. Now what we have to do is we have to take these numbers and we have to write it in terms of a polynomial. So don't forget that our 4x cubed, when it's being divided by an x, becomes a 4x squared. So our 4x squared is actually going to become our leading term. Okay, so we have a 4x squared, and then from there you're going to go in descending order, from a square to an x to a constant. So 4x squared plus 13x plus 26, and since you can't have two constants, the last number, as we said earlier, is our remainder, so we have plus 60 over x minus 2. Okay, so that means our final answer becomes 4x squared plus 13x plus 26 plus 60 over x minus 2. Okay, so if we were to divide 4x cubed plus 5x squared plus 8 by x minus 2, we would get our result. And then don't forget that if I were to take our quotient and multiply by our divisor of x minus 2, we would yield the 4x cubed plus 5x squared plus 8. And all I'm doing is showing that it's the same concept of 12 divided by 3 is 4, which means that 3 times 4 gives us a 12. Okay? Alright, so let's try this a second time. This time we're going to do 3x squared plus 17x plus 20 and divide by x plus 4. Alright, so we start by doing x plus 4 equal to 0 and solving for x. We get x equal to negative 4. That negative 4 goes inside the box. We write down our coefficients. Now, notice that our coefficients are positive like they were in the last one. If, for some reason, you had a minus, then make sure that you treat that coefficient as a negative. Okay? We bring our 3 down. We multiply negative 4 times 3 and get a negative 12 and put that underneath the next term. We add, we multiply, and we add. This yields a 3, a 5, and a 0. Now, since the last term is a 0, that means that we do not have a remainder. And the 3 and the 5 are going to form a factor. Okay? If it goes in evenly, which means it has a remainder of 0, then this is going to become a factor. Again, to show how this is written in terms of a polynomial, we take our 3x squared, we divide by x, and we would be left with a x term. So that gives us a 3x. Then we just go in descending order, which becomes a 3x plus 5. And again, the 0 means that there is no remainder. So 3x plus 5 is basically our quotient. So 3x squared plus 17x plus 20 divided by x plus 4 equals 3x plus 5. This also means that if we were to FOIL x plus 4 times 3x plus 5, that would yield a 3x squared plus 17x plus 20. Alright, I have one final example here. This time, why don't you just stop the video, give the, try on your own, and then start up the video again in order to check your answer. Okay, so hopefully you had a little time to try this example. If I go through, I'm going to go through it a little bit quicker, okay? But, reminder, we always start by figuring out how to solve the x minus 2. X is going to yield a 2. We put the little 2 in the box. We write down our leading coefficient, our coefficients. Okay, and notice that since we have some minus terms here, they become negative in synthetic division. We go through, we drop the first number, 6, we multiply and add, multiply, add, multiply, add, multiply, add. Now since our last number is not a 0, that means this 42 is going to become a remainder. Okay, again, in order to figure out how to write this in terms of a polynomial, we have an x to the 4th divided by an x. So if I were to take my exponent of 4 and my exponent of 1 and subtract, I'd be left with a cube. So that becomes a 6x cubed plus 4x squared plus 8x plus 28 with a remainder of 42, which we write over our divisor of x minus 2. Alright, that concludes the video for synthetic division. If you have any questions, feel free to bring them up in class, and good luck.